Hello friends, today we are going to learn about the tool TNRC, tool nose radius compensation. Okay, there are two G codes for that. G42 is for tool nose radius compensation right side and G41 is for tool nose radius compensation left side. Okay, let's come directly to the profile. So this is the profile. Okay, so there is a chamfer and a fillet is there. So let's write a program for that by using g42. Okay, so let's begin the program. Like you know that we always start from the program number, so let's say 69 T0000 G00x0 G00 Z0, then tool call 20707, then G97 S1000 M4, then safety G00 Z2.0 G00 X52.0, then went on. So while G42 and G41 while using this G code, then the program becomes one process for one process. Okay, G42 and G41 is for finishing operation. So finishing operation is going to take and is going to complete in one process. Okay, so after M7 let's write a program over here. G00 G42 X20 Z plus 0.7. Okay, and then G01 X20.0 Z0.0, then G01. So why I write this line where X is 20.0 and Z is 0.7, which is a bit earlier, like from this point. Okay, so while using compensation you have to give the time to get the tool compensated. Okay, so this is the time from this point to this point, and this point is Z0.7. Clear? So after this point we come to point number 1 by writing this line G01 X20.0 Z0.0. Then from 1 to 2 it's again linear, Z minus 10.0, and 2 to 3 we are moving in clockwise direction. G2 X will be how much? 30.0, Z will be minus 15.0 or 5.0. Okay, then 3 to 4 is again the linear. Then write the then what is the G code for linear is G1 X will be how much? At point number 4 what will the X coordinate for X is what? The measure die is 50, then subtract 10 mm from that, so it will become 40. So X 40.0. Then 4 to 5 is again linear, so G1 X will be how much? 50. Let's take over here 50.3, and Z will be how much? Z will be 10 plus 5 to 10 plus 5 20 20.3. Okay, then take the tool in 50 G1 X 52.0 G40 G00 J2.0. Okay. G97 T00 M5 M9 and G00 G00 M30. Okay, so what is the reason behind using tool nose radius comparison? To get the actual fillet or chamfer. Okay, to get the actual fillet of radius 5 and chamfer 5 plus 45, we have to use compensation, tool nose radius compensation. Okay, so while writing this program in Fanuc controller, okay, we have to remember two things, R and T. Okay, and that thing you will get in the display by pressing offset button from the hard key, then again where from the horizontal soft key. Okay, so these two things are important. R is the tool nose radius. Tool nose radius. Okay. For finishing, we generally take 0.2 mm. Tool nose radius. Okay. And T is the tool tip position. Tool tip position. Clear. By writing this line means you have to focus on this diagram. Clear. So what is tooltip position? While operating on this profile, your insert will be like this. Clear. Your insert will be like this. So match this thing with this thing. So you will get this value, which is 3. Okay. So 1 and 2 is for internal operation, 3 and 4 is for external, 7 and 5 is for your what? Drilling. 6 is external, 6 is again internal, 8 is again external. So this is the kind of neutral insert, which means they can cut in both directions, forward or backward. Okay, so the tool tip position will be T3. You have to put that value in that table. Okay, R will be 0.2, T will be 3. This thing, you have to remember this thing. Okay, R value will be 0.2 and T value is 3. So this is all about the tool nose radius compensation. Okay, the program starts from here and ends over here at M30.